In this session, we are going to deal with binary encoding of data transfer instructions in ARM. So in my previous lecture, we have seen in detail about the data transfer instruction, what is the purpose of data transfer instructions, and what are the different types of data transfer instructions. If you want to have more details regarding this data transfer instruction, you can go through that video lecture, right? So now we will see what are the basic types of data transfer instruction. So basically data transfer instructions are used for transferring word. So those instructions are LDR and STR, right? Similarly, they are used for transferring half word, that is LDRH and STRH. Then it is used for transferring signed half word, so LDRSH and STRSH. It is also used for transferring byte of data, that is LDRB, STRB, LDRSB and STRSB. So these are the different types of data transfer instruction. Now we will move on to the binary encoding of data transfer instruction. So this is a binary encoding for single word and unsigned byte data transfer instruction. So here bit number 0 to 11 is used for specifying the offset used in LDR or STR, and this offset can be given in two ways. Either it can be given as a 12-bit immediate value, or the offset value can be stored inside a register known as RM. So RM is an offset register, right? Then bit number 4, if you are using this type of offset register, then bit number 4 will be represented as 0. Bit number 5 and 6 will be specifying the shift type, right? The shift type can be logical shift left, logical shift right, arithmetic right, or arithmetic or rotate right. So based on that, these 2-bit values will be given here, right? Then finally bit number 7 to 11, it is used for providing an immediate shift length on the register. So whatever offset you have specified in this RM can be shifted by using this immediate value. So if we are using register for storing the offset, the binary encoding will be like this for the initial 12 bits. Otherwise, you can give directly 12 bits offset here, right? Then bit number 12 to 15, it is used for encoding the destination register RD, right? Or source register RM, right? So if you are using load instruction, this RD will be specifying the destination register, because for load you are loading from memory to register. If you are writing store instruction, this RD will be representing the source register. You should keep in mind, because in the case of store, you are storing from register to memory. So in store, RD will be specifying the source register. Then Rn, that is bit number 16 to 19, it is used for encoding Rn register. It is nothing but the base register used for LDR or STR. The next bit number 20, it is used for representing whether you are writing an LDR instruction or STR instruction. If you are writing an LDR instruction, this L bit will be 1. You can see here. If you are using LDR, L bit will be 1. If you are using STR, L bit will be 0. So you can remember like this: 1 bar 0. 1 bar 0. 1 means load, 0 means store. Right. Then the next bit, 21st bit, is used for representing whether you are using write back or not. So if you are using the exclamation, this write back bit will be 1. If you are not using the exclamation, write back bit will be 0. Then bit number 22, it is used for representing whether you are writing a byte oriented LDR or STR, or whether you are using a word LDR or STR. So unsigned byte LDR or STR, or whether you are using word LDR or STR. So if you are using LDRB or STRB, then it will be in the category of unsigned byte. So this B bit will be 1. So if you are using LDRB or STRB, B bit will be 1. If you are using normal LDR or STR, then it will be byte oriented. So B bit will be 0, right? Then the next bit, bit number 23, it is used for representing whether you are adding the offset with the base address or whether you are subtracting the offset with the base address. So if you are adding the offset with the base address, this bit will be 1. If you are subtracting the offset with the base address, this bit will be 0. So again it is represented as 1 bar 0. 1 means you will be adding offset, 0 means you will be subtracting offset. Then bit number 24, it is used for representing whether you are writing a pre-indexed or post-indexed LDR or STR. If you are using pre-indexed, then this bit will be 1. If you are using post-indexed, P bit will be 0. Then bit number 25, it is used for representing whether you are using an immediate offset or offset register. If you are using an immediate offset, bit number 25 will be 0. If you are using a register offset, bit number 25 will be 1. Then bit number 26 and 27 will be reserved as 0 and 1. It is already fixed. Finally, bit number 28 to 31, these are the condition bits. So based on the condition, whatever you are writing in the instruction, these condition bits will be set. Now we will see in detail about this binary encoding with the help of an example. So I am writing an example LDR R2, R0, R4. So here what does it mean? R0 will be pointing to a base address, right? So that base address will be added with the offset 4, right? So whatever base address is present in R0, that base address will be added with an offset 4, and content of that address, that is base address added with 4, content of that address will be taken to R2, right? So R2 will be having the content of address pointed by R0 plus 4, right? So this is the instruction. So now we will see the binary encoding of that instruction. So in this case, you will be using this part of this binary encoded format. That means since you are specifying the 12-bit immediate offset, that is immediate offset you are specifying, so you will be taking this part. We will not be taking this one, we will be taking only this part, because 12-bit immediate address offset you are specifying in the instruction itself. So here bit number 0 to 11, that is 12 bits, are used for representing 12-bit immediate offset. So in our case, what is the immediate offset? 4. So if you are representing 4 in terms of 12 bits, it will be like this: 0 0 0 0 1 0 0. Right, this will be the 12-bit equivalent of 4. Next 4 bits are used for representing source or destination register. In our case, since I am using LDR instruction, I am using what type of register? Destination register. That is why it is shown in red, destination register. Because in load, you are loading from memory to a register. So here my register is destination register. So here what is my destination register? R2. So R2 can be encoded as 0010, 0010. Next 4-bit, bit number 16 to 19, it is used for representing Rn. Rn means it is nothing but your base register. Rn means it is nothing but your base register. So here base register is R0. So it will be encoded as 0000. Then the next 20th bit is used for representing whether you are using load or store instruction. Here, since I am using load instruction, this L bit will be written as 1, right? Because it is written load bar store and it is 1 bar 0. So since it is LDR instruction, this bit will be encoded as 1. Next bit is used for representing the write back, whether you are using write back or not. So write back is represented by the exclamation mark. Since I am not using the write back, exclamation mark is not there, so this W bit will be 0. Next bit is used for representing whether you are using an unsigned byte or word load or store. In my case, I am using word oriented load. That is why LDR is there. So since LDR is there, B bit should be 0. You can see here it is byte bar word. Since I am using word operation, this bit should be 0. Then the next bit will be U bit. U bit stands for whether you are adding the offset with the base address or whether you are subtracting the offset with the base address. In my case, you are adding offset with the base address, so U bit will be 1. If you are adding the offset, U bit will be 1. If you are subtracting the offset, U bit will be 0. You can see here 1 bar 0. 1 means you are adding the offset. Next bit is used for representing whether you are writing pre-indexed load or store or post-indexed load or store. Right? Since in my instruction I am using pre-indexed, this P bit will be 1. Again you can see pre-indexed bar post-index. Pre-indexed means 1, post-index means 0. So since I am using pre-indexed, P bit will be 1. Then 25th bit is used for representing whether you are writing a 12-bit immediate offset or you are using an offset register. In my case, I am using 12-bit immediate offset, so bit number 25 should be 0. So since I am using 12-bit immediate offset, bit number 25 will be 0. Then next two bits are reserved, it will be 0, 1. Finally, the last 4 bits are used for representing the condition code. In my case, LDR R2, R0, #4. Here, what is the condition bit or condition code? Here I have not specified any condition code. So, whenever you are not specifying a condition code, it will be taken as always. So, AL will be your condition code. And what will be the corresponding code for AL? 1110. That means always this instruction will be executed. Right? So this will be the binary encoding for this corresponding instruction. Next we need to convert this into corresponding hexadecimal value. For that I am grouping it into groups of 4. So what will be this value? It will be E5 9 0 2 0 0 4. So E5 90 2004 will be the binary encoded value of this instruction. Next instruction I am writing LDRB R2, R0, #4 exclamation mark. So what is the difference between this instruction and previous instruction? Here I am writing LDRB and I am using a write back here. Right? So again, since I am using immediate offset, I am using this part for encoding. So you can see that from bit number 0 to bit number 20, all the binary encoding is same as what you have seen in the previous case. But the next bit, 21st bit, is used for representing the write back. Right? So here, since exclamation mark is there, write back is enabled so that the address present in R0 will be updated. So write back is there. So write back bit will be written as 1. Right? Then next bit number 22 is used for representing whether you are writing an unsigned byte or a word oriented load store. Here I am using an unsigned byte load. Why? Because I have written LDRB. So since my instruction is of size of type unsigned byte, this B bit should be 1. Previously it was 0 because you are using word oriented instruction. Then the remaining bits will be same as what you have seen in the previous example. Right? So in the next step we are going to convert into hexadecimal value so that you are grouping into 4. Now you can see that the value will be, what will be the value? E5 F0 2004. E5 F0 2004. So here only difference is in the case of write back and this B bit, W bit and B bit. All the others are the same. Next we will see STRB instruction. Previously we have seen LDRB. Now we are going to see STRB. So only difference is in the bit number 20 onwards. From 0 to 19 it is same as the previous one. Bit number 20, what you are specifying? It is used for specifying whether you are writing load or store. Here I am writing store instruction. Since it is store, what should be L bit? It is written like this, load bar store. Since it is store, this L bit should be written as 0. Since it is store, L bit should be 0. And remaining all the other bits will be same as what you have seen in the previous case. Here write back is also there, so it is also 1 that we have seen in the previous case. Then we can convert it into hexadecimal value. Here the value will be E5 E0 2004. Right. Next instruction is LDRB R2, R0, hash -4 exclamation. So here what is the difference between previous LDRB? I have added one minus sign here. That means you will be subtracting the offset from the base address. So base address -4 will be performed here. So the binary encoding will be same as from bit number 0 to 22, it will be same. But the next bit, it is used for representing U bit. U bit stands for whether you are going to add the offset with the base address or you are going to subtract the offset from the base address. So it will be up bar down. If you are going to add, this bit will be 1. If you are going to subtract, this bit will be 0. So now you are going to subtract the offset from the base address. So U bit should be what? U bit should be 0. So U bit should be 0. Then the remaining bits will be as same as what you have seen before. Right. So now we are going to convert into hexadecimal value. So it is nothing but E5 70. Previously it was other value. Now it is 70. Then 2004. This 7 is the difference from this one and previous one. In this example, we will see an instruction LDR R2, bracket R0, R1, LSL hash 3 exclamation. So here instead of using 12-bit immediate value, you are storing the offset inside a register, right? So instead of 12-bit immediate offset, you are using a register offset, and whatever value you have stored inside the register, you are shifting it by 3 units, right? So here the instruction encoding, you will be using first part as this one, and the second part will be used as this section. We will not be using the 12-bit immediate value section. Why? Because you are giving the offset inside a register and corresponding shift you have given. So this section will be used. Why? Because you are specifying the offset inside a offset register along with a shift value. Right. So we will see the binary encoding for this. So bit number 0 to 3, it is used for specifying the offset register. Here my offset register is R1. So these bits should be 0001. Right. My offset register is R1. So bit number 0 to 3 should be 0001. Next bit is reserved. That is fourth bit is reserved. It should be 0. The next two bits, bit number 5 and 6, it is used for representing the shift type. In this instruction, you have used logical shift left as the shift type. So for representing logical left, bit number 5 and 6 should be 0, 0. You can see here. If it was logical right, that is LSR, it should be 0, 1. But here it is LSL, so it should be 0, 0. Next bit number 7 to 11, it is used for representing the immediate shift length that is to be applied on the value stored in offset register. So here the immediate shift length is 3. Why? Because we have referred LSL hash 3. So 3 is the immediate shift length. So it should be decoded as or encoded as 00011. 5-bit immediate shift length you can give. Since the shift length value is 3, you are writing it as 00011. Then the remaining bits will be same as what you have seen in the previous section. Why? Because the only change in this example is you have used a register offset. So if you are using a register offset, only bit number 0 to 11 will be changed as what you have seen now. All the other bits will be same as what you have seen in the previous example. Now we will see the hexadecimal representation. It will be E7 B0 2181. So this will be the binary encoded format of this instruction. Next we will move on to the next type of binary encoding for the data transfer instruction, half word and signed byte. Previously you have seen binary encoded format for unsigned byte and word. Now we are seeing the binary encoding for half word and signed byte data transfer instruction. So here you can see, so in the previous case, in the previous binary encoding format, you are using 12-bit offset, but here you should keep in mind you are using only 8-bit offset. Only 8-bit offset you are using in this case. But it is splitted across two positions. Bit number 0 to 3, it is used for specifying the 4 bits of LSB 4 bits of immediate offset. Bit number 8 to 11, it is used for representing the MSB 4 bits of immediate value. That is bit number 4 to 7 will be represented here. Bit number 0 to 3 will be represented from 0 to 3. Then the next bit will be 1. Again it is reserved as 1. Then 5th and 6th bit it will be representing what type of load or store you are using. That is a SH instruction. SH bits will be used for representing the type of load or store. If it is 0 1, it will be unsigned half word. If it is 1 0, it will be signed byte. If it is 1 1, it will be signed half word. And if it is 0 0, it will be swap instruction that we will see later. Now we are dealing with only data transfer, so only these three combinations will be there. If you are using unsigned half word, it will be 0 1, signed byte it will be 1 0, signed half word it will be 1 1. Then bit number 7 again it will be reserved as 1. So bit number 0 to 11 will be encoded like this if you are using immediate value as the offset, and if you are using a register offset it will be encoded like this. 0 to 3 will be used for encoding the offset register, and bit number 8 to 11 it will be reserved as zeros. So here you should keep in mind, if you are using half word or signed byte load or store, what is the difference? Your shifting cannot be applied on the offset register. Shifting cannot be applied on offset register, you should keep in mind. Right? Then bit number 12 to 15 will be used for representing the source register or destination register. If it is load, it will be destination register. If it is store, it will be source register. Then 16 to 19 it is used for representing base register. L bit it is used for representing whether you are using load or store. If you are using load, it will be 1. If you are using store, it will be 0. Next bit is used for representing whether you are using write back or not. If exclamation mark is there, it will be 1, otherwise it will be 0. Then bit number 22 is used for representing whether you are using immediate offset or register offset. If it is immediate offset, 22 bit will be bit number 22, bit will be 1. If it is immediate offset, it will be 1. If it is register offset, it will be 0. You should keep in mind. Then U bit will be used for representing whether you are adding the offset or whether you are subtracting offset. If it is 1, that means you are adding offset. If it is 0, that means you are subtracting the offset. Then P bit, 24th bit is used for representing whether you are writing pre-indexed or post-indexed. 1 stands for pre-indexed, 0 stands for post-indexed. Then bit number 25 to 27 will be reserved, it will be all zeros. Finally 28 to 31 will be used for representing the condition code. So here you can give only 8-bit offset. Your 8-bit offset will be represented in 2 sections, you can see here. So now we will see one example for this binary encoding. So I am writing an instruction LDRH, that is of type half word instruction R2 comma bracket R0 comma #30 exclamation. So this also can be written in this format. So what is the difference here? Instead of writing #30, I am writing it as hash and 1e. So whenever you are using hash, the next data what you are writing will be taken as a decimal value. If you are writing hash, the data will be taken as decimal. If you want to write the data as a hexadecimal, you need to add one and also. So hash and 1e means 1e will be taken as a hexadecimal offset, right? So both are same, you can use any one of this value. So we will see the binary encoding for this. So in this case you are using this section, right? Because here since you are using 8-bit immediate offset, you are using this part, right? And the main part as this. So here the bit number 0 to 3, it is used for representing offset L. That means LSB 4 bits of immediate value. So bit number 0 to 3 of immediate value will be represented here. So in our case, what is my immediate value? 1e. 1e means what will be the LSB 4 bits? It will be nothing but e. Right. So e can be represented as 1110 and the MSB 4 bits will be 0001. That will be specified in the next section that we will see here. So now offset L, that is LSB 4 bits of E will be 1110. E means 1110. Then the next bit will be reserved, that is 1. Then bit number 5 and 6, it is used for representing the SH type. SH type stands for what type of instruction you are using. Here I am using half word load. So half word load means it is unsigned half word load. So it will be 0, 1. Since it is unsigned half word load, it is encoded as 0, 1. Next bit again it will be reserved as 1. Then bit number 8 to 11, it is used for representing the higher 4 bits of offset, that is bit number 4 to 7 of offset value. So since my offset is 1e, what will be bit number 4 to 7? It will be nothing but 1, that is 0001. So since I am having the higher 4 bits as 1, I am writing it as 0001. So my offset 1e will be represented or splitted into 2 sections. This is 1, that is 0001. Then E will be 1110. Then the next 4 bits are used for representing your source register or destination register. Since I am using load, my register is destination register. What is the destination register here? R2. R2 will be encoded as 0010. Bit number 16 to 19, it is used for representing the base register or Rn. Here my base register is R0, so it is encoded as 0000. Next bit number 20, it is used for representing whether you are writing load or store. Since I am writing load, this bit will be L bit will be 1. Next bit will be used for representing write back. So here since I am using exclamation, write back is there, so W bit will be 1. Bit number 22 is used for representing whether you are giving an immediate offset or a register offset. Here I am using an immediate offset. So whenever I am using an immediate offset, in this case bit number 22 should be 1. You should keep in mind it should be 1. But in the other unsigned byte and word it was 0. But here it should be 1. Then bit number 23, it is used for representing whether you are adding the offset or you are subtracting the offset. Here since I am adding the offset, U bit should be 1. Next, bit number 24 is used for whether you are using pre-indexed or post-indexed addressing mode. Here, since I am using pre-indexed addressing mode, this bit should be 1. Then the next 3 bits should be reserved as 0000. Then last 4 bits will be used for representing condition code. Since here I am not writing any condition code, I am assuming it as AL. So it will be decoded as 1110. So the corresponding hexadecimal value will be, what will be value? E1 F0 21BE. So E1 F0 21BE will be the binary encoded format of this instruction. Next we will see STR-SB. Previously you have seen STR-H. Now you are using STR-SB. SB stands for signed byte. So again this part will be used. So here the only difference is there in the bit number 5 to 6, 5 and 6. That is SH type. So here since you are using signed byte, SB stands for signed byte, bit number 5 and 6 should be 10, 10. All the other bits will be same as what you have seen in the previous example. Only difference is there in SB. So the difference will be there only in 5 and 6. So when we are taking the hexadecimal value, it will be E1 F0 21DE. Then next one you are using LDR-SH. SH stands for signed half word. So again only difference will be there in the case of 5 and 6. Since it is signed half word, this bit 2 bits will be 1 1. All the other bits will be same as previous example. So the hexadecimal value will be E1 F0 21 FE. You can see here. So in this example, what is the difference between this example and the previous one? LDR-SH R2 comma bracket R0 comma R3. So here in the previous example you are using immediate offset, but now I am using a register offset. That means my offset value will be stored inside a register known as R3. So R3 will be my offset register. So here for encoding you should take this first section and you should take this part as, since you are using offset register, right? You should omit this part where you are using the immediate value. Since you are using offset value stored in a register, you should use this section. So what will be the bit number 0 to 3? 0 to 3 will be used for representing the offset register. Since my offset register is R3, it should be encoded as 0011. So these 3 bits are used for representing offset register. Next bit number 4 will be again reserved, it will be 1 as seen before. Then bit number 5 and 6 will be nothing but SH. SH stands for signed half word, so it should be 1 1, same as previous one. Then bit number 7 will be reserved, it will be reserved as 1, you can see here. Then bit number 8 to 11 it will be again reserved as 000. Why? Because in the previous case you are using these bits for representing the shift value that has to be applied on the offset register, but in this case, that is whenever you are using unsigned half word and signed byte binary encoding format, these bits will be zeros. Why? You cannot give shifting operation in this binary encoded format in the case of unsigned half word or signed byte or signed half word LDR or STR, right? So here the shifting is not possible. So these 4 bits should be zeros. We have already told this. Then the remaining bits from bit number 12 to 21 it will be same. It is used for representing destination register, base register, load and write back. Then the next bit number 22 will be different because it is used for representing the immediate operand. Since I am using offset register offset, what should be this value? This value should be 0. In the previous case, when you are using immediate offset, this value should be 1. But now this bit number 22 should be 0. Then the remaining bits will be same as what you have seen in the previous example. So this is how you are finding out the binary encoding for this instruction. So the corresponding hexadecimal value will be E1, B0, 20, F3. Thank you.